Welcome to the AI Research Roundup. I'm Alex. Alright, today we're looking at a paper from the Hugging Face trending list, published on August 11th, 2025, so just 2 days ago. This paper introduces ASearcher, an open source project that helps AI agents get much better at finding information, achieving up to a 46.7% gain on a key benchmark. The paper is titled, Beyond 10 Turns, Unlocking Long Horizon Agentic Search with Large-Scale Asynchronous Reinforcement Learning. It's all about improving what the authors call search intelligence. Basically, an agent's ability to resolve tricky queries and conduct thorough exploration. Also, the authors shared their full implementation on GitHub, and it's a really comprehensive framework. Listeners will find everything needed for Agentic RL training, including datasets, the data synthesis agent, training details, and model weights. They even provide detailed guidelines for building and training your own customized search agents. On Hugging Face, you'll find their 7, 14, and 32 billion parameter models, plus quick start guides for building your own web or local knowledge search agents. And these charts from the paper really highlight the core findings of the ASearcher project. The bar chart on the left shows the performance boost from their reinforcement learning process, with significant jumps in the agent's score on benchmarks like GAIA and XBench after training. Then, the two line graphs to the right illustrate the long horizon search capability. They show that during training, the number of tool calls sometimes peaked at over 70, with the agent generating over 150,000 tokens for a single task. This diagram shows a side-by-side comparison of their system with a more standard approach. On the left, we see a more conventional agent, which they call Search R1. It's limited to using a search engine and can only take 10 turns or less. But on the right, ASearcher adds a web browser and a summarization tool. Critically, it can handle up to 128 turns, which is what allows it to learn those really deep, multi-step search strategies to find complex answers. This figure provides a great case study on a complex question from the GAIA benchmark, comparing 3 different agents. The first agent, Search R132B, gets completely lost. It hallucinates and ends with the wrong answer. The second agent, Search O1QWQ, does a bit better, but misses key information and also fails. In contrast, the ASearcher Web QWQ agent successfully navigates the problem by using advanced strategies like cross-document inference and grounded verification to arrive at the correct answer. So to get an agent to perform these complex searches, you need really good training data. This diagram shows the clever process the authors built to create it. They start with the seed question and answer pair on the left. Then, an agent automatically makes the question harder using 2 methods. Injection adds new, related facts to the question, while fuzz makes parts of it more ambiguous. Finally, on the right, every new question is put through a quality verification process to ensure it's still solvable but challenging. This table then gives us some great examples of that process in action. In the top section, a simple question about a person's birth date gets progressively harder. First, 2 rounds of injection add a lot of extra context, which you can see in red. Then, a fuzzing action, shown in cyan, makes a specific name like Catskill Mountain Railroad more vague, changing it to a historic mountain railway. This transformation forces the agent to do much more work to connect the dots and find the correct answer. So training on these complex, long horizon tasks creates a major efficiency problem, which this diagram illustrates perfectly. In the top half, you see a standard approach called one-step-off reinforcement learning. Here, the system gets blocked by very long tasks, like Trajectory 7, creating a lot of idle time, where expensive hardware is just waiting. In contrast, the bottom half shows their fully asynchronous reinforcement learning system. By decoupling task execution from model training, it eliminates that idle time, making the entire process much faster and more efficient. So by putting all these pieces together, the efficient asynchronous training and the high-quality synthetic data, the ASearcher project really pushes the boundaries of what open-source search agents can do. The key takeaway is that enabling long-horizon reasoning is critical for tackling complex, real-world questions. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.